On April 15, 1943, at 20,000 feet above the French coastline near Dieppe, Major Donald Blake's gloved hand gripped the control stick with increasing tension. Through the haze of clouds below, his Lee-equipped P-47 had picked up something distinctive, the unmistakable outline of enemy aircraft breaking through the cover. After weeks of grueling training flights interrupted by constant mechanical gremlins with the newly arrived Republic P-47 Thunderbolts, the 4th Fighter Group was finally closing in on actual combat. The massive American fighters, which British pilots had jokingly dismissed as 7-ton milk bottles, were about to demonstrate what they could really do. Blake kept the German Focke-Wulf 190 of JG-26 Schlageter firmly in his gun sight, completely unaware he was about to become part of aviation history. When the distance closed to 300 yards, his finger found the firing button. 8 Browning AN-M2 .50 caliber machine guns opened up at precisely the same moment, each one hammering away at 800 rounds per minute. The sheer volume was staggering, 6,400 rounds streaming downrange every single minute. Armor-piercing incendiary rounds tore into the German fighter, and within seconds the Focke-Wulf simply came apart. That single engagement marked the P-47's first aerial victory and signaled the beginning of something far more significant, a complete shift in how aerial warfare would be fought. The Republic P-47 wasn't merely another fighter plane. It represented something entirely different. An airborne weapons system built on an entirely American principle, maximum firepower delivered through maximum production. But how did it all begin? The P-47's combat debut actually happened on March 10, 1943, when the 4th Fighter Group carried out their first fighter sweep over France. Radio malfunctions turned that mission into a disappointment, forcing everyone back to base where British radio gear got hastily installed. During those early months of 1943, the 4th Fighter Group, which had previously flown as the RAF's Eagle squadrons, found themselves wrestling with an enormous challenge, transitioning from nimble Spitfires to these absolute giants called Thunderbolts. The numbers told the story. The P-47 tipped the scales at 12,731 pounds when empty and climbed to 17,500 pounds, fully loaded with fuel, ammunition, and armor. That was more than double what a Messerschmitt Bf 109G weighed. Republic Aviation's factory in Farmingdale, New York, wasn't slowing down either. By April 1943, they were rolling one P-47 off the assembly line every 4 hours, with production ramping up constantly. Alexander Kartveli, the Georgian-born designer who led the effort, had adopted a philosophy that European engineers found absolutely baffling. Where German designers obsessed over shaving off every possible gram, Kartveli kept adding machine guns, ammunition drums, and armor plating. Colonel Hubert Zemke, commanding the 56th Fighter Group, grasped what the Americans were really doing. His unit arrived in England that January and was flying combat missions by April. The 56th would go on to become the only 8th Air Force group to fly nothing but P-47s for the entire war, eventually tallying 674 aerial victories. The firepower math was straightforward and almost brutal in its simplicity. Early P-47C and P-47D variants carried 350 rounds per gun, 2,800 total rounds. The 8 guns positioned for wing delivery created something called a convergent fire zone at 250 yards, where all those bullet streams came together in the same deadly space. Anything caught there faced something unprecedented in single-engine fighter combat. 1 second of continuous firing sent 107 half projectiles downrange, each traveling at 2,140 feet per second. When Germany's intelligence services got reports about 8 heavy machine guns on a single-engine fighter, they initially dismissed it as impossible. The whole concept violated everything their engineering philosophy dictated. German thinking had always emphasized efficiency, just enough firepower to get the job done, nothing wasteful. Conservation of every ounce meant better performance. The Focke-Wulf 190A, the main German fighter over Western Europe that spring, carried a pair of 7.92mm MG-17 machine guns with 1,000 rounds each, plus two 20mm MG-151 Shut-20 cannons with 250 rounds per gun stowed in the wings. Those 20-mm shells, though individually far more destructive than 50-caliber bullets, meant German pilots had to be very selective about when and how they squeezed the trigger. They'd developed attack methods built entirely around ammunition conservation, short, precise bursts from close range. That whole approach had worked reasonably well against British Spitfires and Hurricanes, which typically flew with either 8 303 machine guns or some combination of machine guns and cannons, all carrying limited ammunition supplies. Following Blake's victory on April 15th, encounters between P-47s and German fighters multiplied rapidly. Just 2 days later, on April 17th, the 4th Fighter Group's P-47s flew their first bomber escort mission, though the early drop tank designs had serious range restrictions that forced them back to base sooner than everyone hoped. What struck German pilots immediately was the psychological impact. 8 guns creating a visual spectacle unlike anything they'd seen before. The P-47's standard ammunition mix, 4 armor-piercing incendiary M8 rounds, followed by 1 tracer M10, meant every 5th projectile glowed as it traveled. From a distance, this created the eerie impression of one continuous beam of light, rather than individual bullets streaming through the air. By May 1943, the Luftwaffe's Technical Evaluation Center was tearing apart captured P-47 components, trying to understand what they were really facing. German engineers discovered that the Browning AN-M2 machine gun, despite being a 1933 design, had been refined through mass production to achieve something they couldn't match: genuine interchangeability. Any component from any gun fit perfectly into any other gun without adjustment or modification. That level of standardization simply exceeded what German manufacturing could accomplish. The ammunition feed system, using disintegrating link belts, ejected cleanly from the aircraft. German fighters relied on either 60 to 200 round drums or belt systems that hung onto the links afterward, adding extra weight and complication. The American design's reliability meant P-47 pilots could, if they absolutely needed to, dump their entire ammunition supply in one unbroken stream. American ammunition production, on the scale being achieved, left German analysts stunned. By mid-1943, the 8th Air Force was flying more than 200 P-47 sorties every single day. With each plane carrying 2,800 rounds and pilots typically expending roughly 60% of their ammunition, that added up to around 336,000 rounds getting fired into the air daily. That exceeded the entire weekly ammunition allocation for Germany's complete fighter force in France. The Lake City Army ammunition plant in Missouri alone had reached production capacity of 1.6 billion rounds annually by 1943. This solitary facility outproduced Germany's total small arms ammunition industry. The place hummed continuously with 20,000 workers rotating through shifts, maintaining such strict quality control that any round deviating more than 1,000th of an inch from specifications got rejected. Republic Aviation's manufacturing performance rivaled it. The Farmingdale plant sprawled across 765,000 square feet, with additional production happening in Evansville, Indiana. By late 1943, the combined output hit over 400 P-47s monthly, while German fighter production of every type combined struggled to exceed 1,000 per month. German fighter design had always emphasized lightweight, maneuverable airframes. The Messerschmitt Bf 109G6 weighed just 6,840 pounds loaded. The Focke-Wulf 190A5 came in at 9,040 pounds. The P-47C, by comparison, weighed 13,500 pounds loaded. The P-47D reached 14,500 pounds, impossibly heavy according to everything German doctrine taught. Yet the P-47's Pratt & Whitney R2800 double wasp engine, producing 2,000 horsepower initially and 2,300 in later variants, delivered competitive power-to-weight ratios despite that bulk. The extra weight provided benefits Germans hadn't prioritized. It created a rock-solid gun platform and gave the airframe the ability to absorb tremendous punishment. The General Electric turbo supercharger system alone weighed 845 pounds, nearly the entire armament allowance German fighters allocated. But that supercharger maintained full power at 30,000 feet. Altitudes where the BMW 801 radial engine in the Focke-Wulf lost significant power above 20,000 feet. Encountering the P-47's firepower forced the Luftwaffe to completely rethink their tactics. Traditional attack methods became suicide missions when P-47s were involved. American fighters didn't require perfect firing position. Their volume of fire created kill zones that German fighters simply couldn't survive crossing through. Luftwaffe units scrambled to develop new approaches, relying on the Fokker-Wulf's superior roll rate and turning capability at low altitude. The problem was that reaching low altitude meant diving through the P-47's fire envelope, and American pilots quickly learned to exploit this. They used their altitude advantage and sheer firepower to force German fighters into positions where they were at complete disadvantage. The ammunition situation revealed the starkest contrasts. German pilots entered combat with 60 to 90 seconds of firing time total. P-47 pilots carried enough ammunition for 30 to 35 seconds of absolutely continuous firing. This fundamental difference created vastly different combat philosophies. Germans carefully managed every round. Americans fired liberally, almost recklessly by comparison. The first Schweinfurt-Regensburg mission on August 17, 1943, demonstrated both what P-47s could do and where they fell short. When P-47s could provide escort, they devastated German interceptors. The 56th Fighter Group alone claimed 17 victories without losing a single plane. But the P-47's range, even equipped with 75-gallon belly tanks, limited them to roughly 375 miles from their base. German controllers exploited this limitation perfectly. They simply waited for the P-47s to turn back before launching their attacks. The result was catastrophic: 60 B-17s shot down, which made it crystal clear that longer-range protection was desperately needed. Yet within the P-47's umbrella of protection, bomber losses approached nearly zero. Progressive installation of 108-gallon and later 150-gallon drop tanks stretched the range further. By October 1943, P-47s could escort bombers out to 425 miles. Each additional mile meant German fighters had to wait longer and travel farther before engaging, and every extension worked in the Americans' favor. The entire support structure behind P-47 operations reached industrial dimensions that bewildered German observers. Each P-47 squadron kept reserves totaling 500,000 rounds. Forward bases scattered across England stockpiled millions more. Supply ships ceaselessly delivered ammunition from American factories. A typical P-47 group carried sufficient ammunition for 30 days of all-out operations without receiving any resupply whatsoever. German fighter units operated on 3-day reserves, often considerably less. American pilots blazed away, while German pilots rationed every single round. Maintenance and supply presented similar disparities. American depots maintained complete spare engines, replacement gun sets, and every major component imaginable. Damaged P-47s could be rebuilt using spare parts within days. German units, by contrast, cannibalized damaged aircraft for components, systematically reducing their operational strength even when the airframes might theoretically be repaired. October 14, 1943, Black Thursday, the second Schweinfurt raid represented a real turning point. As P-47s flew escort to their absolute maximum range and claimed 21 German fighters, the bombers once again faced devastating assaults after the Americans had to depart. German pilot reports started revealing genuine concern about engaging P-47s. The mathematics were inescapable and increasingly grim. A German fighter squadron of 12 aircraft might possess 7,000 rounds total in various calibers. A single P-47 squadron with 16 aircraft carried 44,800 rounds of heavy machine gun ammunition alone, with millions more sitting in reserve. The firepower advantage wasn't just numerical, it was amplified by training differences that had become increasingly severe. American P-47 pilots arrived for combat with 400-plus flight hours behind them, including 100-plus hours of dedicated gunnery training. They'd fired thousands of practice rounds downrange. German pilot training by late 1943 had deteriorated to averaging just 110 flight hours before facing combat, with perhaps 20 hours of gunnery work. Fuel shortages meant many German pilots had fired their guns only a handful of times before engaging enemy aircraft. They faced American pilots who had burned more ammunition during training than they would fire during their entire combat service. Lieutenant Colonel Francis Gabby Gabreski, who would finish the war as the leading P-47 ace in Europe with 28 victories, captured the tactical reality plainly. They didn't need to be better marksmen, he said, they just needed to put their sight on the target and hold the trigger. The 50s did the rest. By November 1943, P-47 groups began adding ground attack missions to their escort duties. The 50 caliber guns proved devastatingly effective against locomotives, vehicles, and parked aircraft. Armor-piercing ammunition could punch through locomotive boilers and vehicle armor plating. A single P-47 could obliterate an entire train in one diving pass. The standard approach involved a 30-degree dive, starting fire at 1,000 yards, working the rudder pedals to scatter bullets across the target, then pulling out at 200 feet. In just 10 seconds, a P-47 could deposit 800 to 1,000 rounds into a target area stretching 100 yards. German transportation networks faced systematic destruction. P-47s were eliminating locomotives faster than German industry could manufacture replacements. By December 1943, German units simply stopped attempting rail movement during daylight hours. The P-47 interdiction had become too lethal. The P-47's contribution to the strategic bombing campaign proved crucial. Although the P-51 Mustang would eventually take over the long-range escort mission, P-47s had provided the essential shield that kept the bomber offensive alive despite grievous losses. Early 1944 brought improved P-47D variants carrying 425 rounds per gun, 3,400 total. The P-47D-25 introduced a bubble canopy, paddle blade propeller, and provisions for carrying rockets in addition to the guns. These enhancements kept the P-47 effective even as German fighters evolved. June 6, 1944, D-Day, delivered the ultimate demonstration. P-47s flew 2,398 sorties, claiming 84 German aircraft destroyed in air combat and 89 more on the ground. More significantly, they throttled German ground movement through systematic interdiction. The Luftwaffe managed only 319 sorties over Normandy that entire day. Americans flew over 13,000. German fighters across Normandy probably possessed around 200,000 rounds total ammunition. American fighters carried millions, with limitless resupply flowing continuously. P-47s essentially created free fire zones where anything moving became a target and got destroyed. Vehicle columns turned into burning wreckage in single passes. That distinctive high-pitched whistling sound of diving P-47s, air screaming through gun ports and cooling ducts, became itself a terror weapon. By late 1944, German fighter production actually peaked at 25,000 aircraft annually. But with fuel becoming desperately scarce, pilot losses mounting, and overwhelming numerical superiority arrayed against them, most never flew operationally. Those that did face odds exceeding 10 to 1 in many sectors. The Messerschmitt Me-262 jet fighter offered speed advantages but didn't deliver firepower superiority. Its 30mm Mk108 cannons carried only 80 to 100 rounds per gun, 360 rounds total, placing German pilots in an impossible situation against an opponent firing thousands of rounds into the sky. The P-47 proved devastating against bomber formations, yet its limited ammunition supply and relatively modest muzzle velocity meant it struggled when facing agile fighter opponents in head-to-head combat. The Pacific variant, the P-47N, brought a revolutionary advancement to the table. It carried 550 gallons of fuel internally, a staggering amount when you consider that this single-seat fighter held more fuel than entire German medium bombers. This fact alone speaks volumes about American industrial might and the ability to manufacture aircraft that shattered every conventional design expectation. The production figures paint a remarkable picture of industrial competition. Republic Aviation built 15,680 P-47s across their facilities, with some months seeing over 400 aircraft roll off assembly lines from multiple plants. Germany, by comparison, manufactured approximately 20,000 FW-190s of all variants between 1941 and 1945, with roughly 13,000 being fighter variants. Despite these impressive numbers, the Americans achieved something Germany could not sustain. Every P-47N left the factory completely armed with 8 machine guns and sufficient ammunition to keep them firing. German pilots, meanwhile, flew increasingly compromised aircraft. By 1945, ammunition shortages forced many FW-190 pilots to operate with only 2 cannons, instead of the standard 4, a painful reminder of dwindling resources. Republic Aviation's manufacturing sprawl covered more than 1 million square feet of production space under one roof. German fighter production, by stark contrast, operated from facilities constantly under bombardment, with plants scattered across the country in desperate attempts to avoid destruction. This dispersal crippled efficiency. The Lake City Army ammunition plant alone churned out 1.6 billion rounds each year. When combined with other American facilities like Frankfurt Arsenal, Des Moines Ordnance Plant, and Twin Cities Ordnance Plant, American production exceeded an extraordinary 10 billion rounds of 0.50 caliber ammunition throughout the war. Germany managed approximately 4 billion rounds of all aircraft ammunition calibers combined. Think about that stark difference. Americans produced more ammunition for a single machine gun caliber than Germany produced for every aircraft weapon type put together. The difference in quality control was equally stunning. American ammunition underwent rigorous inspection at multiple stages, with rejection rates holding steady at just 2 to 3%. German production, increasingly dependent on slave labor and substitute materials, struggled with far higher malfunction rates that directly reduced combat effectiveness. The U.S. Strategic Bombing Survey documented what P-47s actually accomplished over Europe. They destroyed 3,916 enemy aircraft through aerial combat and another 3,202 on the ground. But the ground attack role became their most devastating contribution. P-47s destroyed 9,000 locomotives, knocked out 86,000 railway cars, eliminated 68,000 motor vehicles, and destroyed 6,000 armored fighting vehicles. These weren't just tactical victories, they represented devastating strategic impact. Every locomotive destroyed, every rail line severed, represented a crippling blow to Wehrmacht mobility and supply lines. The Luftwaffe simply could not mount effective opposition to these devastating low-level attacks, meaning American air power essentially operated without serious challenge. American pilots who completed 25 missions got rotated home to train new generations of pilots. German pilots flew until they were killed, captured, or too damaged to continue. By late 1944, the Luftwaffe's pilot corps consisted mostly of inexperienced newcomers facing seasoned American veterans who'd already survived dozens of combat missions. That experience gap only widened. American training programs constantly incorporated lessons learned in actual combat. German training, disrupted by fuel shortages and compressed by desperate necessity, produced pilots with wildly inconsistent skill levels trying to counter standardized American tactics that leveraged every advantage. Beyond raw firepower, the P-47 incorporated technological features of remarkable effectiveness. The turbo supercharger maintained full engine power even at extreme altitudes where normal engines would struggle. The R-2800 engine ran reliably, requiring overhaul only after 400 flight hours of operation. The K-14 gun sight, introduced late in 1944, performed automatic deflection calculations using gyroscopic principles. Pilots simply aimed at their target and fired, while German fighters still used basic reflector sights, requiring pilots to estimate deflection by hand. Weapon heating systems prevented gun freezing at altitude. P-47 machine guns functioned perfectly at 40,000 feet, in temperatures dropping to -60 degrees Fahrenheit. German fighters regularly experienced gun freezing problems above 25,000 feet, particularly the wing-mounted weapons that took the worst of the cold. American abundance extended to every aspect of operations. P-47 groups maintained extensive spare parts inventories, complete engines on hand, gun sets, propellers, everything needed to keep aircraft flying. A ground crew could completely replace an engine overnight. Battle damage that would require weeks of German repair shop time got fixed in days. By late 1944, German fighter serviceability had collapsed below 50%, while American P-47 units routinely maintained 85% serviceability rates. American crew chiefs were highly trained specialists with formal technical education. German ground crews had been gutted by conscription, increasingly filled with foreign workers, and Hitler Youth with minimal training. P-47s burned 130 octane aviation fuel, allowing higher manifold pressures and increased power output. German synthetic fuel manufactured from coal delivered inconsistent octane ratings that degraded performance and reliability. By late 1944, German fighters received perhaps 30 to 50 gallons per sortie when fuel appeared at all. P-47s routinely carried 370 gallons internally, plus external tanks. American pilots flew multiple missions daily, while German pilots sat grounded, waiting for fuel trucks that never came. When German pilots did fly, aggressive maneuvering consumed fuel needed just to return home. American pilots flew without fuel anxiety, enabling aggressive tactics German pilots simply couldn't match. The P-47 embodied American industrial philosophy: overwhelming quantity of adequate quality, not perfection in small numbers. Germans pursued technical perfection with limited production runs. Americans pursued adequate performance produced in unlimited quantities. Cartwright's design prioritized manufacturing ease over optimization. The P-47, despite greater complexity, was actually easier to manufacture than German fighters. Standardization and mass production meant faster output at lower cost. This philosophy extended throughout the entire supply chain. The same 0.50 caliber rounds fired by P-47s armed bombers, ground vehicles, and naval vessels, simplifying logistics while achieving economies of scale impossible with diverse calibers. German attempts to match American firepower proved futile. The FW-190A8, introduced in February 1944, could carry additional cannons in underwing pods, but the added weight and drag severely degraded performance. The Sturmbok variant, optimized for bomber destruction with heavy armor and 30mm cannons, proved helpless against escort fighters. The fundamental problem transcended engineering. Germany lacked the industrial capacity to simultaneously fight on multiple fronts while matching American production. Any attempt to do so only accelerated resource exhaustion. Beyond physical destruction, P-47s achieved psychological victory. The distinctive whistle of a diving P-47 became a terror weapon. German soldiers developed persistent anxiety about P-47 attacks, diving for cover at any aircraft sound. American pilots understood their psychological advantage perfectly. They flew with confidence drawn from unlimited resources. German pilots flew from desperation born of scarcity, and this mental state affected tactical decisions. Germans increasingly avoided combat unless absolutely necessary. The P-47 achieved a 4.6-to-1 kill ratio across over 746,000 sorties. Though 3,499 P-47s were lost to all causes, this represented less than 0.5% loss rate per sortie. German fighter units suffered 50% monthly casualties by late 1944. The 56th Fighter Group, flying exclusively P-47s throughout the entire war, became the top-scoring American fighter group in Europe with 674 aerial victories, proving that supposed P-47 limitations were overcome by firepower, durability, and pilot skill. The 8 0.50 caliber guns represented far more than firepower. They embodied American industrial philosophy triumphant. Each gun required precision manufacturing and complex supply chains. That America could mount 8 per fighter and sustain ammunition supplies demonstrated industrial supremacy, transcending military calculations. Military historians recognize P-47 firepower as decisive in achieving air superiority over Europe. The ability to deliver overwhelming firepower at extended ranges broke the Luftwaffe's defensive capability. Once air superiority was achieved, Allied victory became inevitable. The P-47's influence extended well beyond World War II. It established principles that continue dominating modern air combat. firepower superiority through volume of fire, standardization enabling mass production, and industrial capacity determining military capability. Modern fighters carrying rotary cannons, firing 6,000 rounds per minute, descend directly from P-47 philosophy. Precision-guided munitions represent evolution rather than rejection of the firepower principle, another form of overwhelming force through industrial superiority. When West Germany rebuilt its air force during the 1950s, it adopted American equipment, tactics, and doctrine. German pilots trained on American aircraft, fired American ammunition, and absorbed American air combat philosophy. The student learned from the master. Beyond statistics, individual accounts reveal the human dimension. Colonel Robert S. Johnson of the 56th Fighter Group survived an attack on June 26, 1943, that punched over 200 bullet holes through his P-47. The aircraft absorbed damage that would have destroyed any German fighter, flying home with damaged controls and a shattered canopy. Colonel Hubert Zemke, commanding the 56th Fighter Group, developed tactics maximizing P-47 advantages. His Zemke fan spread squadrons wide, creating overlapping fields of fire that German fighters couldn't penetrate. Under his leadership, the 56th achieved remarkable success, flying exclusively P-47s. German pilot Heinz Knoke, author of I Flew for the Führer, described facing P-47s as confronting streams of tracers that seemed like solid sheets of fire, making bomber approaches through escort screens virtually impossible. His memoir provides valuable German perspective on American firepower superiority. Behind every statistic stood millions of American workers producing the arsenal of democracy. At Republic Aviation's Farmingdale plant, women comprised 40% of the workforce by 1943. These workers built P-47s with precision exceeding peacetime standards, while maintaining unprecedented production rates. Lake City Ammunition Plant operated continuously, workers producing billions of rounds in climate-controlled facilities. Quality control inspectors, mostly women, rejected ammunition that varied even slightly from specifications. Their dedication ensured American pilots never experienced ammunition failures plaguing German fighters. American workers earned good wages, lived comfortably, and took pride in their contribution. German production increasingly depended on forced labor in deteriorating conditions, resulting in sabotage and declining quality. The P-47 program cost approximately $1.3 billion in 1940s currency, representing massive investment in a single weapon system. Yet American industrial capacity made this affordable while simultaneously producing thousands of other aircraft, tanks, and ships. American mass production continuously reduced unit costs. Early P-47s cost over $100,000 each. By 1945, unit cost had dropped to $83,000 despite increased capability. German fighter costs increased throughout the war as production dispersal and material shortages reduced manufacturing efficiency. Post-war analysis revealed the gulf between American and German production methods. American factories used specialized machine tools, assembly line production, and statistical quality control. German production retained craft methods unsuitable for mass production. The Browning M2 design facilitated mass production with simple, robust components manufactured by semi-skilled workers using automated machinery. German weapons required skilled craftsmen using traditional methods. This fundamental difference meant America could expand production exponentially, while Germany could not. The P-47's 8 guns represented synthesis of American advantages: industrial capacity, technological innovation, logistical excellence, and training superiority. No single element proved decisive. Their combination proved overwhelming. Industrial capacity provided the foundation, the ability to produce fighters, guns, and ammunition in vast quantities. Technology enabled effectiveness through turbo supercharging, reliable engines, and precision manufacturing. Logistics delivered materials where needed. Training ensured pilots could exploit advantages. Germany possessed excellent pilots, innovative technology, and tactical sophistication, but without the industrial foundation supporting them, these advantages proved insufficient. The Luftwaffe was defeated not by superior tactics, but by overwhelming material superiority symbolized by 8 guns firing continuously. German pilots facing P-47 Thunderbolts learned harsh lessons about modern warfare. Their FW-190s, excellent fighters by traditional standards, were overwhelmed by American firepower delivered through industrial production. 8 0.50 caliber machine guns supplied with unlimited ammunition represented new warfare paradigms. The transformation from confidence through shock to acceptance mirrors Germany's larger World War II experience. Initial tactical superiority based on innovation and skill crumbled against American mass production and material abundance. The P-47, initially dismissed as too heavy, proved that industrial might could overcome tactical disadvantages. German pilots were stunned not just by 8 guns firing in unison, but by what those guns represented: a nation producing unlimited weapons, ammunition, and aircraft. The FW-190 might have been superior by traditional standards, but traditional standards had become obsolete. The P-47's 8050s rewrote air combat rules through industrial power. The legacy endures in every modern fighter emphasizing firepower over finesse, every massive munitions expenditure, and every industrial approach to military challenges. All trace their lineage to the moment German pilots first encountered 8 synchronized Browning machine guns and realized their entire understanding of air combat had become obsolete. The P-47 Thunderbolt didn't merely outgun the FW-190. It outproduced, outsupplied, and ultimately outthought German aviation philosophy through overwhelming firepower delivered by industrial democracy. The 8 guns were never just weapons. They were messengers of American industrial might. Every burst demonstrated production capabilities Nazi Germany could never match. The thunderous roar of 8 synchronized Brownings became the sound of inevitable Allied victory, a sound that echoed from American factories to the skies over Europe, forever changing the nature of aerial warfare.